Okay, this is going to be an intro into momentum just because I don't want to explain the same concept throughout each individual video and question. In my eyes, I think that this is a harder topic than the other one, so I'm going to kind of briefly go over my thinking before I get into the actual questions. I should note, impulse and momentum is actually unit 4, whereas the other stuff is unit 3, technically, at least as far as I'm aware. So I think the decision to kind of group them up together as if they were the same is a bit questionable. But whatever, I'm sure there's a reason for that. I think it's probably for AP prep time or whatever. Anyways, Imma just go through everything impulse, or I guess sort of the reasoning, right? Later on, I'm gonna make some assumptions, I'm gonna kind of substitute things in. This is why I'm doing it. This is how, and this is why it makes sense, right? So our usual equation for physics is F is equal to ma, right? F as in force is equal to the mass times acceleration. This is pretty standard stuff. We've done this throughout the unit or throughout the year, right? We are using the same formula now, except we're kind of reshuffling it a bit. So in its most traditional sense, A, or acceleration, is just equal to change in velocity over change in time. We know this, we've done this, this makes sense. We're just taking this and we're plugging it back into A. So we end up getting F is equal to mass times change in velocity over change in time. Then we take this T and we stick it over here with the F. So we get F times the change in time is equal to M times the change in V. We get this on the reference sheet, I think. I mean, it's not that hard to memorize, but it should be on there. If it's not that hard to memorize. But this is not a different formula to this. It's just rearranged algebraically. This all is logical. What's not logical is them decide whoever them is. I don't care, but whoever made momentum equal to P is stupid. I don't like how P is the symbol for momentum. I think that's dumb. There's probably a reason for it, but whenever I see, the symbol P, I don't think of momentum. I think of like power or something, right? But it means momentum. And this is just equal to M times V, or yeah, which that's just what this is. And this can get broken down into change of P, which is just P final minus P initial. And this stays the same, right? So our ultimate equation for these sort of impulse problems is just going to be force times the change in time is equal to the change in P, which is just broken down into P final minus P initial. I should mention these are vectors, which is kind of why I don't like grouping it up. Like, I don't agree with the decision of grouping it with energy, just because energy is a scalar quantity, work is scalar, but this is a vector, which means direction does matter, which is why I think grouping them together is a bit kind of, I don't like it, right? So, anyways, this means that your minus signs, your direction does matter. There is going to be arrows for the most part over your values. Um, and that's really it. I mean, all you have to know is that P is equal to MV. And when in the previous unit, right, we would kind of take work and we take energy final minus energy initial, and we would spam this formula for like every single question we got. We're doing the same thing now with force times the change in time is equal to P final minus P initial, right? We're just taking the same thing and applying it again and again and again and again, right? So not a totally foreign concept, but the equation has changed a little bit. So you can see question one peeking out over there. I'm gonna get to that like right now, but just keep in mind this everything I've just written down is kind of the basis of what I'm gonna be going off for this packet. Um, this what is like the most standout color? This like orange, right? This is the most important thing. This is the formula we're going to be spamming throughout. And P is ultimately equal to M times V. P as in momentum. Again, I don't think of momentum when I see P. Whatever. I don't even care. I care. Momentum. Whatever, man. All right. So P is momentum. And it's equal to mass times velocity, which is just this formula, which we use for everything. Cool. Cool.